Welcome to today's class. Today we continue studying the graphical representation of piping isometric drawings. First, let's examine valve symbol representations. Common valve installation positions are drawn with thin solid lines, as shown in the table's layout views, and corresponding isometric drawings. Valve handwheels are shown as short lines parallel to the pipe. Valve stem center lines follow their designed orientation. Gate valves, globe valves, angle valves, throttle valves, T-valves, ball valves, T-ball valves, and plug valves have distinct symbols. Ball valves and plug valves are easily confused. Pay close attention to their differences. Next, let's explore pipe support representations in isometric drawings. Pipes typically require various types of supports. Supports are fixed to the ground or structures. Supports are represented by symbols in layout drawings. Support numbers are labeled beside the symbols. A support number consists of 5 parts. It is represented by a combination of letters and numbers: order, support, type, structural base, zone code drawing suffix, and support sequence. Let's break down these 5 components. First, support type. See table. A for fixed, G for guide, R for sliding, H for hanger, S for spring hanger, P for spring support, E for special, T for axial stop. Second, structure base. See table. C for concrete, F for foundation, S for steel, B for equipment, W for wall. Third, zone code, single digit number. Fourth, drawing suffix, single digit number. Fifth, support sequence, 2-digit number starting from 01. Let's continue with support symbols. See the figure below showing 3 types. Picture A for with shoe, G for guide, S for steel structure. Picture B for without shoe or other forms, A for fixed, F for foundation. Picture C for pipe number, including supports for multiple pipes, R for sliding, S for steel structure. Next, let's understand the labeling of the piping isometric drawing. The dimensions and labeling methods for the piping isometric drawing are as follows. First dimension, all pipes, fittings, and valves for fabrication and installation. This ensures installation accuracy. Firstly, specify the distance from the primary reference point to one flange face of the valve or pipeline component, such as dimension A and elevation B in the diagram. Secondly, for control valves and certain special pipeline components, such as separators and filters, the face-to-face dimensions of their flanges must be specified. For standard valves and fittings, this is not required, such as dimension C in the diagram. Thirdly, when standardized fittings are directly connected to each other, their length dimensions generally do not need to be specified. However, if the position of the pipeline or branch is involved, it should still be indicated, such as dimension D in the diagram. Finally, more on dimensioning. Second, each pipe segment must have a flow direction arrow. Label the pipe number near the arrow if possible. Third, elevations use meters. Other dimensions use millimeters. Fourth, dimension lines extend from fitting center lines or flange faces. Dimension lines align with the pipe. Fifth, vertical pipes omit height dimensions. Use elevation marks, like elevation X, XX point, X, XX. Sixth, use a wavy line. For approximate dimensions, label F.W for field welded dimensions. 7th, label connected equipment tags and nozzle numbers. 8th, list the material table to indicate the required materials, dimensions, specifications, quantities, etc. For the pipeline section in this lesson, we covered valve symbols, pipe supports, and dimensioning in isometric drawings. I hope you understand and master these concepts.